we're going to look at some word problems, and for each word problem, we're going to come up with a linear model and an exponential model using that same set of data. So we have 2 points for each of these, and that's what we're going to use to construct our functions. So in year t equals 0, a lake is estimated to have 3,500 trout in it, and 10 years later at t equals 10, the population of trout is believed to be about 1,700. So I have 2 points here. I have the point 0, 3,500, and 10, 1,700. So those are the 2 points I have. So if we assume the decrease is linear, what is the rate of change in fish per year of the function over the 10-year period? And then we're going to write a formula for that. All right, so when we're finding this rate of change, we're looking for the slope of our linear function. So I'm going to do m is equal to, I have 1,700 minus 3,500 over 10 minus 0. So I'm subtracting the dependent variables over the subtraction of the independent variables. If I run that into my calculator, I get about negative 280. So what that means in context of the problem is that we lose approximately 280 trout per year. And then our formula here, so for a linear function, we can use either the point slope form or the slope intercept. And since I have the intercept here, I'm going to use slope intercept. So y is equal to mx plus b would be what it looks like generically that we remember it. But our variables are a little different here. I have p and t. So I have p is equal to negative 280t plus 3,500. So that's my initial population. So there's my linear model for this. And then if I assume that it's exponential, what is that exponential model going to look like? So I get a b to the 10th is equal to 1,700 over ab to the 0, which is 3,500. So 10 minus 0 is 10. So I get b to the 10th is equal to, and if I divide this, I get about 0.4857. And if I raise that to the 1/10th power, so I take the 10th root, I get b is approximately 0.93. So that population is decreasing about 7% per year. All right, and then my formula here, so I know my initial population is at 3,500, so it does make this easier. I already know what A is. So P is 3,500 times the 0.93 to the T. And that would be my exponential model for that.